Hey, Easton. There is still a lot of work to be done, obviously, but this totally gets the point across. Um, I guess before I really put pen to paper and figure out how much the linear bearings are going to cost me and size the air cylinder and everything and get you a quote, um, my plan is to split this project into two projects. To me, the drilling portion really belongs on the weld fixture, and I know there's going to be some pushback there, but I think I can explain why that's the best spot for it. Um, and then, of course, the drilling and the tapping portion is sort of the easy part because we already said that the Atlas Copco torque tool will do it. And so we just have to design an air cylinder to push on the drill, and the torque tool does the rest. As far as the grinding is concerned, I think the best spot to do that is on the walking conveyor. I think it has to be on the first station because there's already a clamp that holds the axle down. And every time that an axle comes out, the four spots that we're grinding are in the same position, and it's a known position in that first spot. So the automation for this gets really simple. As soon as an axle is clamped in position, then I would trigger an air cylinder to extend. As the air cylinder extends, the air cylinder would be mounted under here. As the air cylinder extends, I'd be pulling on a cable that's clamped to the rod so that it stays centered. And then everything that you see here would be mirrored on the other side. And so when the cable pulls this mechanism in, it's going to keep both sides centered. And then basically what I've thought is for longevity's sake, a very long 1-inch thick sanding belt would be ideal. I think you could probably get many days of use out of that before you had to replace the belt. We could certainly do some testing to figure out how many days and how much a belt costs, but I'm not sure how you want to proceed, so I thought this video was a good way to get started. Basically, Dave and I designed a tool that the belt tensioner would keep these rollers extended. So as I pull down on the belt, the rollers are going to want to return to this open state, which has an angle on the belt. Let's see if I can show this a little better. So at this point, the belt is not touching the axle. But then when these arms close down, there's 100 thousandths overlap between the apex of this circle and this one. And so we'd be pushing down on that axle 100 thousandths, so you get a little bit of an area there, certainly enough to take away that small divot left behind by the shear. So the way this would work is when the cylinder extends, it would pull on the cable, which would push this into position. So this goes back far enough to clear the longest axle. And then as it comes in, when it hits position, it's going to get to a spot. So the belt tensioner would be keeping this arm like this, and then this is going to come in, and once it hits the axle, it's going to come down, right? So that when it's down, like I said, we're going to be grinding in that position. So then we'll just have a timer, and we'll let it grind on those 4 spots for however much is appropriate, and then the air cylinder would retract. Everything goes back home, and we should be able to grind those same 4 spots every time. So to me, this was the most complicated portion. I want to see what you think before I start. There's still obviously a lot of modeling to do. Linear bearings, slides. I think because the cable is only going to be good at pulling, I'm going to have to either create a continuous loop with the cable or have a spring return or something. I still want to talk to you about if we're registering off of this spot on the axle or this spot. So there's still a lot of work to be done, but I think this is good enough to get you. If you wanted a quote, I could do it. Um, if you want to, push me in a different direction, you certainly could. Um, Let me know what you think so far. Thank you.